We are familiar with our traditional looping mechanisms, the for loops, the for each, the map, and the like. Okay, now on my screen I have the for loop. Obviously, what this is going to do is going to loop through our values till it terminates at the condition we set. Okay, this works. Now, today we're going to be talking about iterators and generators. So here I have, in my browser, I have some kind of a teaser or appetizer, so to speak. So, but before we get into this, let's go back to our text editor. Okay, I could have, no, if we already have all of these looping mechanisms, okay, perhaps a way to start in order to enhance our understanding of what we're trying to do is to ask the question, well, we have all of these looping mechanisms. Why do we need iterators and generators? Okay? So it turns out that our regular loops, they have some kind of limitations that iterators and generators they come to address. Okay? And maybe it has to be said now. Iterators and generators, they are not designed to replace our regular loops. What they do, two things. They offer standardization and then they offer efficiency. Okay? Maybe it's better explained, it's better demonstrated than me just narrating it to you. Okay, so I'm still sticking with this for loop. If I have const collection, and then inside this collection, say I do foo, bar, then I do bars. Okay, I can still use this for loop to loop through this. So what I'm going to do is I'm going to expose the length of our collection. Okay, and then here I'm going to use the subscript operator to get the value of each of the items in the array. So if I save this, let me open the console. Sure enough, it works. Full bar bars. Okay. Now, what this is doing is this. Regardless of what we do, we could have used array.map. We could have used the for each method. Okay. What this is doing is known as eager execution. Eager execution in the sense that the loop loops through everything all at once, assigning a new array in memory. Now, because you have 3 items inside this array, the overhead involved in such operation may not be apparent. But say you have like 10 million items in an array, large data set, and then say we wish to loop through such large data sets, and then we're implementing that such a loop with this mechanism. What I'm trying to say is, if we have something like this array, and then we have 10 million dot fill dot map, I'm not going to complete this program. This kind of construct, this kind of operation, depending on the environment you're running it. If you're running it in a browser, there is the potential that it crash your browser. If you're running this in your Node.js server, there's a potential that it crashes your Node.js environment. okay? Because it just looked through everything. It does eager execution, okay? Now, what if there is a way we can implement loops without looping through everything at once? And then we can specify to the loop to go one step at a time. That is what iterators and generators offer us. They offer us what is known as lazy loading, so that the loop doesn't loop all at once and then crashing our environment. Okay, if that works. Um, there is also the issue of where we're trying to loop through collection, objects, data types, wherever, and then we don't have some kind of universal language. What I'm trying to say is this: in our regular looping mechanisms, we realize that the methods for looping through array don't necessarily work for looping through objects or maps. So we don't have some kind of protocol, a universal language, so to speak, that regardless of the data structure we're working with, that looping mechanism will work, if that makes sense. Okay, so this is this is one of the things that iterators and generators trying to help us to solve, to give us some kind of standardization and then a way to manage our data construct structure efficiently. So if we go to our browser, say, what's an iterable, and an iterator? Okay, say an iterable is an object that can be traversed sequentially, allowing us to access its element one by one. Now, an iterator repetitively performs a procedure multiple times in sequence and with the expectation of termination. Okay? Now, I've mentioned this. Iterators and generators offer us an improved approach to looping through something, say a data structure. Okay? Now, to implement this, we're going to have what is known as an iterator pattern. Okay? So the iterator pattern describes a solution in which something can be described as iterable and can implement a formal iterable interface to be consumed by an iterator. Okay? So once a data construct or a data structure is described as iterable, then any or all of these native language constructs, such iterable can implement this. It goes on because I have we have for of loop, array destructuring, spread operator, array dot from, on and on till you get to yield operator. This yield is peculiar to generators. Okay, we're going to get to that in a bit. Okay, let's go back to our text editor. So we're going to have some kind of data structure, okay? And then we have to figure out a way to describe such data structure as iterable. Okay, so if, say, a collection is iterable, for instance, then that collection is going to implement an iterable interface and then to be consumed by an iterator. Okay, so a collection that can implement iterator and generator is iterable, if that makes sense. So let me describe some data structure here. Say num is equals to 2 const string. Let's say okay, string, and then const array. Let's call that foo bar bars. Okay, and then we can have const set, that's new set, and then the way we populate set is to do add. Okay, so let's say 1 dot add 2. So we have some kind of method chaining going on here. Let's keep it at 3. Then we can have const map, which is new map, and then if you remember, the way we populate our map is to use this called set method. So let's say a1 dot set, let's say b2, and I want to use another type of data here. Let me say empty object here, and then here I can do id 1. Okay, and then let me broaden this to node list. Then we have document dot query select all, select all divs. Okay, like that. Now we have all these data structures. We need to establish that they are iterable. One or all of them are iterable. So the way we do that is to expose this to a default iterator by using the symbol, the iterator key on each of these. So I can do console.log num, then I have the subscript operator, and I call symbol.iterator. Okay, this will review whether or not num is iterable. Okay, can go to the next data structure, then I can do string symbol.iterator. The next one is I think that's Harry now. Symbol.iterator. The next one is a console.log set symbol. Okay, symbol.iterator. Okay, we also have map subscript symbol.iterator. Then there's the node list, and then we have symbol.iterator. Okay, now let's see what we get. To go to our browser and open our console. Okay, so the first one, output undefined. The second one, we have symbol.iterator, so native code. The third one, we have values, native code, values like that, entries, values, okay. So out of all of our data type that we specified, one is not iterable, and let's see, that is none. So which none is not iterable, so we cannot implement iterators and generators with none, so we don't need this. So we can just delete this, okay, and then delete this here as well. So every single one of these is iterable. Okay, now don't be confused, because here we have a string, and string is primitive. It's not a collection type, it's primitive. But then here we are getting symbol.iterator. Okay, it's telling us that string is iterable. Now if you recall, we can call some kind of some methods on string. Okay, what is going on there is known as boxing. boxing. Okay, so JavaScript is wrapping the primitive string around objects. Okay, uh, giving us the opportunity to work with string as though it is an object, but it is not an object because the interpreter still interprets it as primitive. Okay, so this is just boxing. It's just a convenience, to work with string. It doesn't change the fact that string is still primitive. It's not an object type. Okay, so we have our default iterator now. It has exposed to us that these data structures are iterable. Okay, so now it has to implement an iterator interface. Okay, so the way we do that, we have to is to which iterator is each of these is going to consume. Okay, let me rephrase that. Now we need to figure out or discover for ourselves which iterator is going to consume these data constructs, okay, all of these iterables, okay. So the way we do that is to call this global constant now or a factory function. So here, so this is our iterator. So if we save this, we go back to the console. You see, we have string iterator. It's telling us what type of iterator is going to consume that iterable. So this first one is string iterator. The second one is array iterator. Third one is set iterator, map iterator, array iterator. So our node list, which is from our document objects, is an array. Okay, good. Now, this doesn't prevent us. We said here, if we go back to our browser, say, when we have an iterable, our iterable can implement any of these native language constructs. So we can still do for of loop, array destructuring, spread operator, so to speak. So if I go back here, I can still do, what is it called now? If I do const iter string, for instance. So instead of logging this to the console, then I can do this. Okay? Then I can do, come here, I can do for const value of iter string. Let's say console.log value. Okay, let's go there. What do we have? So we have our string. Each of the letter inside our string, it's being outputted. We have this, it's been outputted here in the console. Okay, so the leverage the iterator gives us is to do lazy loading. Okay, so let's say our iterator doesn't even know what kind of data structure we're working with. So we can specify to it that it should run the loop one after the other. It should lazy load it because this is still like looping through everything at once. So the way we do that is this. We can do console.log. Okay, console.log enter string dot next. So iter string dot next. So we're calling the dot next method. I'm going to copy this and then paste it a couple of times. Okay, let's let's see what we get. So we go to the console. See? The iteration is occurring one after the other. Oh, wait. So you don't. So that's the first iteration. Let's go. See? It's not looping through everything all at once, unlike our regular looping mechanism. See? We get value, the first value there, which is S, and then we get another property, done, which is Boolean. So for each iteration, we're calling .next method. It goes on to the next iteration. If you save this, it goes on to the next letter in the string. See? And it's not done yet, so we get false. If we go a step further, like that, until everything is done, console.log. Okay, sorry, let me just think I could, okay. Okay, so here, 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 here. Let's see what we get. Then it goes on and on. When the iteration is completed, the next property we get value undefined, done is true, because there's nothing left to iterate. So this, it gives us a more efficient way to manage our data. So we can specify to the iterator what it should how many times it should iterate, not that it should just iterate everything all at once. Okay, we can do for any of this. It could have been, what is it called? It could have been Harry. I'm coming. It could have been Harry, like here. Harry is similar iterator. Yes, let me see whether this works. Next. Okay, so the first value is foo. It's saying done. False. Remember in our array we have foo, bar, bas. Okay, so I'm calling the iterator objects. Calling the next method on. This is better achieved if I had okay, let's say const iter array equals to this. So I have an array. I'm calling the iterator constructor factory function there. So here I can do like the other time, console.log iter array the next. Okay, I'm going to copy this and then paste it. But before I copy it, let me just show you. So we have foo, done, false. Okay, if I copy, if I paste, bar, done, false. You see, one at a time. If I copy again, I save, you get the last one, bars. If I copy again, I'm going to get undefined, then done, true. You see? So this is lazy loading. This is what iterator helps us achieve, okay, unlike our traditional looping mechanism. Okay, we also talked about how we can implement these native language constructs. Okay, so we've talked about for loop. Let's look at array destructuring. So for our array destructuring, I can do const A, B, C, and here I can have I don't know, maybe iter string, iter array, and I can do console.log A, B, C. Let's see what we get. Oh, what have I done? What's that? Oh, I'm sorry. Of course, I'm getting undefined because okay. Let me comment this out and let's see whether that works. Okay, now I'm getting full bar bars. Okay, I was getting undefined the other time because the iteration has completed and there's nothing else, and the code is beneath this .next method. Okay, what else do we have there? We have the spread operator. So if I decide to create a new array, for instance, let's say const new array, and then I can spread what is it called? I can spread height array. Okay, can spread height array, and maybe full bar bars. What is it again? Blast. I don't know. Okay. Then if I do console.log new array, we still get what we have. Okay, full bar bars blast. See, it's not stopping us from. We can even create a new map construct here. Okay, we can create a new map construct. So we say const new map. All right, and then here we have before that. Let me create the pairs equals. I can even use what is it called? I can use my array here, but I want to use this array dot map. Okay, so here let's say we have value index, now return value index like that. Then I can say const new map equals new map. Okay, and then here I can just pass the pairs. Okay, so if I do console.log new map, let's see what we get here. Sure enough, we got new maps, full 0, bar 1, bars 2, like that. Okay, did we have our what is it called? Incoming. If I do console.new map, the next is it gonna work without calling the iterator factory function? Let's see. See, uncaught type error, map new map dot next is not a function. So it's not a function because at this point, see, we've just populated our new map and then we save it inside this variable new map. So at this point, new map is not yet iterable. Okay, so it cannot be consumed by an iterator. Okay, so the way to overcome this is to do new map dot console new map dot no, it's not new map dot, it's new map then symbol dot iterator, and then we call this factory function there. See, so our new map now, see, it's map iterator. So if we now do console.log new map, the next, this works. Let's see what we get. New map.next is not a function. What have I done wrong? New map. peers. What did I have inside my peers? New map dot next. It's not a function. Why is it not a function? I've specified this. Oh, I'm sorry. I think this is the issue. So I have const. I didn't saw in a variable iter new map. So equals new map. So okay. So instead of new map, I can just call iter new map dot next. Let's see whether this will work. Okay, now this works. Okay, so the first value is array. Okay, it's indicating what is it called? You say array length 2, then done is first. So if I go to the next one, I go to the next one, see what we get. Say done is first. I can expand this. So here we have value 2 by 1. The first one we have value to full 0. Okay, so we can go on and on like that till we get to our final iteration. Okay, even for our node list. So we have all kinds of leverage to work with. This gives us a better way to manage our data. Okay, of course, we are not restricted to this. We can create a custom iterator of our own if we want. Okay, so let's get into that. If I have a class counter, for instance, counter, and then I'm going to set a constructor. I'm going to use the constructor as inputs. I'm going to do this dot limit is equals to limit. Okay, so when I instantiate this class, this constructor will fire. Okay, so whatever I pass into that object is going to be what this constructor guy is expecting, which is this input limit. Okay, so I can do, since it's counter, I can do this dot count equals to 1. Okay, and then inside here I can call the next method. Okay, can call the next method, and then inside here I can say if this dot count is less than or equals to this dot limits. Okay, this is our custom iterator. Okay, don't forget that. So I can say return. We're returning object there. So I can say, and the object has 2 properties. That is the value. Okay, so what's the value going to be? Our value is going to be this dot count plus plus, and then our done should be false as long as this condition is met. It's false. Else we can return value continuous value. So let's undefined. Okay, so when the iteration is complete, this is the object we return. Value is undefined, and then done should be true. Okay, and then we have to call our iterator factory function here, which is symbol the iterator. Okay, and then inside here we can return the current object, return this. Okay, now to use this class we have to instantiate form. We have to create an object. So let's call this C, then new counter. I know we've not talked about classes. We're going to get to that in subsequent tutorials, so bear with me for now. So conc new counter. So C is an object, which is an instance of this counter. Of course, this counter is expecting an input through this constructor. At the point of instantiating this class, this constructor function will fire. So whatever we pass inside here is going to be this input that this constructor was expecting. So if I pass 3 here, for instance, okay? So in order for me to consume this class, I have to make use of this variable C, okay? So if I do console.log c.next, fingers crossed, let's see whether it works. Okay, so it works. The first iteration, we get value 1. Done is first. Remember, we are passing 3. Okay? So let's go again. Console.log c.next. What do we get? Now we're getting 2. Done first. Let's go again. Console.log c.next. Next. So for every next method, we're iterating one after the other. So we get the third value. Done is the first. Okay? And then if we go one after the other, if you go one more time, then we have c.next. Let's see what we get. Undefined, done, true, which is a condition we specify here. Say, for as long as count is less than or equals to the limit 3, return this object. Otherwise, return undefined. Done, true. To show you what I mean, I can even do string here if I want. And then I save it, and then here, I'm getting string undefined. Okay? So this is our, what is it called? This is an example of custom iterator. You see? Let's do another one. Let's say we have, what can I do again? I don't know. Let's say we have const aftermath. I don't know. Aftermath. This is all on top of my head. So let's have an object. Let's say lead, Dr. Dre, and then senior. Let's say Eminem, junior. Let's say 50 cents. Okay? Okay. Now, what do we want to do here? We are inside an object, okay? Don't forget. So we can do our symbol.iterator. And then we can try to return whatever we want to return here, okay? So let's have, if I do symbol, this is the global key, symbol.iterator. That's a property of this object now, okay? Then I can have a function here, okay? Then inside this function, let me do const members, okay? And then here, I can populate an array, this dot lead, this dot senior, and then this dot junior. Okay. I have to set an index, right? So I can do let index let index equals to 0 here, then I have to return something. What do I return? Okay, then I say return return an object. Okay, inside this object, let me specify a next key, and then that's the function called an anonymous function. And then here I can say set a condition like if index was less than the members dot length, what do we do? Then we can return value. Okay, what's a value going to be? A value is going to be members, then index plus plus. Hope that is correct. Then done, it's going to be false. Okay, else we can just return. Yes, we can return value. Value is undefined. Value is undefined. Then done is true. Okay. All right. So this is another custom iterator. I hope this syntax that I've written, I hope it works. So there's only one way to find out. So here, if I do const iter obj equals to aftermath, then I can call the symbol dot iterator constructor factory function here. Okay, then if I do console.log iter object dot next, fingers crossed, let's see whether this works. Okay, it works. So the first value, Dr. Dre, done, false. Okay, so let me just explain what I've written here. So we have a, what is it called? We have an object. This object is known as aftermath. Okay, now inside this object, first we're declaring 3 properties: lead, Dr. Dre; senior, Eminem; junior, 50 Cent. Okay, now the next property is the default iterator. Okay, this symbol, the iterator key. Okay, so we are setting it to a function. Now inside this function, we are declaring a variable members, which is an array. So we're populating this with the values here using these.lead, these.senior, these.junior. So lead refers to these, in this context, refers to the current objects. Okay, so then we're initializing a variable known as index, which is equals to 0. Okay, and then inside this function, we are returning an object. This object has a property next. Okay, and then the value is this anonymous arrow function. Okay, now we're saying if index is less than members.length, that is the length of this array, then we are returning this object value. Of course, we're getting the index of the members. Okay, we're getting the value of the members by using the subscript operator to populate the index. So we're incrementing for each of the iteration, and then the other property, which is a boolean, we say okay, fine, for as long as this condition is met, for as long as the loop has not iterated through all of the values we have inside our members, let's have false. Otherwise, let's have undefined and done true. Okay, so I'm declaring a new variable iter object. So here, what I'm trying to do is I'm trying to consume this object with the object iterator. So the way to do that is to expose our object to this iterator. What is it called? It's the global constant now, or what is it called now? To this factory function symbol.iterator. Okay, and then that allows me to call the next method on the what is it called, on the iterable interface now. So the first one is Dre. If I go again, console.log iter object, the next, I think I should get Eminem now. Okay, so value Eminem done first. It means the objects they have value there. So the next one, console.log iter object.next. Now let me do one more. Iter object.next. Okay. So if I save this, go to the console, see, I get 50 cents. And after that, it's undefined. Okay. Now, what generators now, we can re-implement this using generator. Okay. Generator also implements lazy loading. Only that in the case of our generator, we have this special keyword known as yield. Okay, so the yield, it yields our outputs, and then as the case may be, our generator function also, the syntax is not as elaborate as this that we have done here. So look at this, for instance. Look at this. What is it called? Look at this aftermath objects. Look at all the codes we have to write. If I were to implement this iterator, this default iterator using generator, it's not going to be as the code is not going to be as long as this, and I can show you that. So look at this. Okay, and then I hope I'm not jumping the gun. Like maybe I should have shown you how to write an iterator function first, but in any case, we're going to get there. So here you see that asterisk. Okay, then we have symbol dot iterator. Okay, so that's an iterator function now. Okay, so inside here we can now yield. We can yield this dot lead. Okay, yield this dot senior. We can yield this dot junior. Okay, like that. So if I come here, I'm coming. Let me see whether this will still work with generator. So let me just, the first one, let me save and let's see what we get. Okay, so we get Dr. Dre. So the generator is still doing the same thing except with shorter syntax. Okay, so if I uncomment this, it should go to the next one. So it's the first iteration we get, it's yielding the lead. The second one is yielding senior. So if you go here, so Eminem done first. See, we didn't even have to specify to the iterator whether or not it should output done first or whatever. It just does it. Okay, So if we go to the next one, I think now we should get 50 cents. And then when we go to the next one, the iteration is complete. We should get, see, undefined, done, true. Okay? Oh, our construction, what is it called? Our generator doesn't prevent us from using the other native construct as well. So I can do, what is it called? If I do console.log, I don't know, console.log, and then let me spread aftermath here. And let's see what we get. So that's spread operator. Okay. So I'm guessing Dr. Dre Eminem 50 cents. So even though we're using generator, it's still like describing our data, our collection as, see, we're using this symbol of iterator. So when we declare a generator, for instance, say we want to declare a generator function, okay? We have a function, and then we have an asterisk, okay? So let's call counter, for instance, okay? Okay, so let's select high is equals to 0. Then we say y, true. When you use generator, you're going to use, when you use generator functions is a special function. It's a very beautiful function. No, seriously, I'm not making this up. So here I have yield high plus plus. Now, if we didn't use generator here, generator function here, if we didn't use generator function here, and then we do this y true, and then we increment, this is the kind of code that's going to crash your whatever, whether browser or your server or anything. But here we are inside the generator. Our code does not crash. Okay? Because why this is why true. We don't know when this loop might complete, because we're beginning with 0, and then we're incrementing y true. So this condition will always be true. But then we're inside a generator function. So this is not going to crash our browser or anything. Okay? So I can come here, I might even say const result, then I'm going to call counter here. Okay? In fact, wait, console.log result. Let's see what we get. See? Counter suspended. It's not crashing. It's even like suspended. So we even have the leverage. We have the latitude of suspending our function execution when we are using generator. So at this point, you see it's suspended. It's not running. If we were to have implemented that with a traditional looping mechanism, it will just run all at once. It's not even going to stop. It's just going to keep running, because this condition is always going to be true. Okay? And then we can now do this one after the other by doing the next. So this implements the first iteration. So what do we have? Value 0 done first. You see, it's one after the other. This is more efficient, if you ask me, guys. So if you go to the next one, we have console.log result.next. It goes on like that. We get one. It keeps going on like that. You're not going to, if you keep implementing it, unless you at some point you specify some kind of break. Okay? So let's not dwell too long on this. In the course of our subsequent tutorials, we are still going to be coming across this concept. Okay? So let's stop here for now. I hope you've learned something in the course of this session. I hope to see you the next time. Thanks for watching. Bye bye.